Another important definition we are looking at today is the equivalence relation. If you have not seen the video yet on relation, I urge you to do it so, and kindly find the link in the description section. So what comes to mind when you hear equivalence? Then we are talking about what? Equality. Equality. So how do I define an equivalence relation? So it's normally in other books, you realize that it is denoted by this symbol. So you either see this representing the equivalence relation, or you have this or R. So we are saying that a relation, so then I can define the equivalence relation. It's a relation, let's say I'm using this on a set. On a set, let's say the set is what? X. Is said to be equivalent, is said to be equivalent if one, it is what? Reflexive. It is reflexive. Two, it is symmetric. And three, it is transitive. So if I define this, then that makes what? The equivalence relation. What do we mean when we say it is what? Reflexive. So let's look at what it means for it to be what? Reflexive. So if I have, with this example, if I have X, let's say in X, so I'm defining a relation. So let's say I define a relation R, which is from what? X to what? X. So let's say I have X in X. I'm saying that I can define for all, so this is for all X in X, I can define a relation which is what? Reflexive, such that for my X, the ordered pair of X and X is what? In what? R. Let's take an example. Let's say I have X to be the set 2, 3, and 4. I can build a set of ordered pairs, which is my relation. I can find a relation which is a set of ordered pairs 2 and 2, 3 and 3, then 4 and 4, which is in what? R. If I have this, you realize that my X, we are saying that X is related to what? X. So it is reflexive. It is reflexive if for all X in X, I have what? X related to what? X. That is what we mean when we say it is what? Reflexive. What about symmetric? So for symmetric, let's say I have X. If I have X and Y in X, what it means is that I can have an ordered pair X and Y, which is what's in my R. This implies that my Y, X is also what's in R. An example is, if I have X to be equal to 1, the sets 1, 2, and 3, I can build a relation which is a set of ordered pairs of what? 1, 2. Then I have what? Don't forget I have 2, 1 as well in it. So this is what we mean. My x, y is in R, and yx also is in what? R. So it is transsymmetric if and only if for all x, y in what? My x, and I have, this implies that if x is related to y, then my y is also related to what? X. So that is what it means. So I can write x related to y will be equal to what? Y related to x. This is what? Equivalence. Then the last one we are looking at is transitive. Transitive. So for transitive, you realize that if I have x, let's say I have x, y, z in what? That's my x. Let's say if x is related to y and y is related to z, this implies that my y is also related to what? Z. That is what for transitive as well. So example, let's say I have my x, I still have 1, 2, 3. You realize that if I want to write a relation, I'll have what? 1, 2, let's say 2 and 3 and what? 1 and what? 3. So 1 is related to 2, 2 is related to 3. This implies that 1 and 3 are what? Also what? Related. So in other books, you either find them writing x is related to x, or you find the other way round where you have what? X is related to y if and only if y is also related to what? X. Or if x is related to y and y is also related to z, this implies that x is related to what? Z. So this is what our equivalence what? Relation, which is very important in looking at what? Functions.